system with a compressor, evaporator, thermostatic expansion valve or TXV, and condenser as the main components. The thermostatic expansion valve is mounted in front of the evaporator, with the bulb and external equalizing line mounted on the suction line just after the evaporator. Generally, TXVs are used to regulate the amount of refrigerant liquid being injected into the evaporator. They do this by controlling the refrigerant superheat at the evaporator outlet. As a consequence, these valves are especially suitable for liquid injection in so-called dry evaporators, where the superheat at the evaporator outlet is proportional to the evaporator load. Certain TXV versions can also be used to reduce the superheat on systems with capacity regulation performed by hot gas bypass valves. Schematic of a refrigeration system showing what happens with the refrigerant in the four main system components. Firstly, between points 1 and 2, the pressure of the refrigerant vapor is increased by the compressor. Refrigerant leaves the compressor as hot vapor at high pressure. Next, between points 2 and 3, the refrigerant is cooled down in the condenser, thereby condensing, from vapor to liquid. Refrigerant leaves the condenser as a subcooled liquid. Pressure is not changed in the condenser. Then, between points 3 and 4, the liquid refrigerant expands because of the pressure drop in the throttling device, thereby dropping in both pressure and temperature. Refrigerant leaves the throttling device as a mixture of vapor and liquid at low pressure. Finally, between points 4 and 1, the refrigerant is heated in the evaporator, thereby evaporating, the remaining liquid to vapor. Refrigerant leaves the evaporator as superheated vapor. Pressure is not changed in the evaporator. As mentioned in a previous slide, the throttling device, from now on called thermostatic expansion valve, controls the superheat at the evaporator outlet point. 1. Because the compressor can be damaged if liquid enters it through the suction connector, it's important to always maintain a certain minimum level of superheat in front of the compressor. The simplest way of doing this is to use a fixed throttling device, such as a capillary tube. This is typically done in, for example, household refrigerators and in other simple systems where optimization is not a selling point. A fixed throttling device can, however, only be effective for one set of operating conditions. This is where the TXV has a huge advantage. Because the TXV is a modulating valve, it will regulate the injection of liquid refrigerant in the evaporator in proportion to the actual operating conditions. This means it prevents liquid passing to the compressor independent of operating conditions. For the expansion valve to operate correctly, it's important to always have 100% liquid in its inlet connection. To guarantee this, it's important to maintain a certain minimum of subcooling in the liquid line. Point 3. If this is not possible, flash gas may develop in the inlet of the throttling device, and this will lead to starvation of the evaporator because of a drop in the injected amount of liquid. The TXV senses the bulb temperature at the evaporator outlet. The bulb temperature is, by means of the evaporating charge, converted into pressure, P bulb, which through the capillary tube is transferred to the top side of the diaphragm. The evaporating pressure, P evap, is led to the underside of the diaphragm, either through the external equalizing connector or through a hole inside the valve. Together with the force from the valve mainspring, F spring, the two pressures achieve a pressure balance which represents the requested superheat, or SH, at the evaporator outlet. Depending on the actual SH value, the TXV orifice will open or close. If the load on the evaporator increases, the increasing superheat will in turn increase the bulb temperature or pressure. This will open the TXV orifice, so more refrigerant is injected. If the load on the evaporator decreases, the decreasing superheat will in turn decrease the bulb temperature or pressure. This will close the TXV orifice, so less refrigerant is injected. In this slide, you can explore the way the TXV valve works. Click on the gray button in the bottom right corner to start the animation.